start.
Yes. Now, welcome to our session, Remote Graphic Workloads and Clients, the 2020 edition. This is the second edition, and we created this session since Rodi and I do a lot of GPU projects. And one time we did a project at the customer, which invested a lot in a GPU optimized Nutanix cluster. And they tell me like, okay, maybe we just have to buy cheap clients since we already invested a lot in the hardware. So we learned a lot of things testing a lot of clients. So we want to share this with you in this session. So meet the team. Rodi, you first.
Yeah. Hi, my name is Rodi Koster. I'm a lead consultant at Picor. I'm working mainly focused on the workspace. I'm a Citrix CTP. I'm part of the NVIDIA NGC program, so heavily into GPUs.
Yeah. My name is Patrick van der Born. I'm an independent consultant in the Netherlands, and I'm a member of the Citrix Technology Advocates. And I'm also writing some blogs for Go AUC, and we're both a member of the Team RGE community. So some kind of agenda for today. We will start with some basic of codecs, then the different protocols of all the vendors. Then we will speed something up at the physical clients and our lab setup, how we captured all that information. Then we'll tell you something about the native clients of those vendors, the HTML5 clients, and then we will give you some common graphic settings so you can bring that along in your own environment and some lessons we've learned. As you start, three key takeaways. So first, get basic knowledge of protocols to make the right decisions in your environment. And a lot of vendors are telling you any place, anytime, any device, and especially any device is not true. Like you have a different user experience on different devices. So always testing your environments with your conditions and your applications. During the session, we have recorded some client user experience, and since the frame rate is not that great on GoToWebinar, we have a YouTube playlist. Alex, I've sent you the link in the question. Maybe you can share that to the audience, or just scan the QR code, and then you can view the movies at the correct frame rate.
Yeah, just 1 second.
Yeah. Now we will start with the basic of codecs.
Yep.
Oh, that's a nice video. Oh my God.
Yeah.
Oh, what is? Oh my God.
We sent a special link for you, and yeah. So to start with the codecs, there are so many terms that you will see around in documentation or on the internet, in blogs, describing the different codecs. So things like HEVC, YUV444, H264, Chroma Sub-sampling, BT2020, and I can go on and on and on and on. There are so many different things that describe a codec or have influence on a codec or on the screen quality. So to know what an encoder does, you need to know the basics. So let's first start with colors. And colors are very perceptive. So the color that I see is not the same color that you see. And we also have people that are colorblind. But it's also funny if you, for example, look into the sun or keep your eyes shut for a minute or so and open your eyes again. Then the colors you experience around you are different than the colors you saw before. So colors are really perceptive, and it's really our brain that, or our mind, that plays tricks with us sometimes. So for example, here on this checkerboard, we have the box with the A in it, and we have a box with B in it. Do you think those are the same types of gray? If I look at this picture, I will say no, right? A is in a dark gray area and B is in a light gray area. But what if we connect them? Then suddenly it's the same color. And it really is the same color. So if you don't believe me, take a screenshot of this picture put it into paint.net or something, use the color picker, and you will see that the RGB values of those two are really the same. So our mind sometimes plays tricks with us in terms of color. And that's also visible in this gradient. So we have a big gradient here, and we have a gradient which is reversed in the middle. But the bar in the middle isn't a gradient. It's just a plain gray bar. So if I just go back one slide, you will see again that it goes from light to dark, and the big gradient goes from dark to light. And because it goes from dark to light, our mind plays a trick with us, and it will also put a gradient on the gray bar. So again, if you don't believe me, just take a screenshot, remove the gradient like I did here, and you will see it's just a plain gray bar. So it's funny that our brain does play tricks with us. It's like being drunk, but then without alcohol. So in computer environments, the amount of color is the color bit depth. So it's the amount of different colors. And it can be used in two different ways. So one is the number of bits used to indicate the color of a single pixel. So for example, 24-bit. Or it can be used for each color component itself. So the amount of red, green, and blue. So for example, 8-bit. And it can be combined with alpha, which describes transparency. So some mainly of the most commonly used colors, and I think the most common one these days is 24-bit true color, which means 8 bits per color, which is roughly around 16 million colors. The next one we'll see more and more on Blu-ray videos and games is 30-bit color, or 10 bits per color, which is 1 billion colors. And that's more than our eyes can even see. But it all has to do with the gradients or the smoothness of colors. So for example, in the left picture, you will see a 10-bit color information. So the transition from dark blue to light blue, from light orange to dark orange is really smooth. And on the right side, you will see an 8-bit color information, and you will see gradients. So you will start seeing lines where there's not enough color information to do a smooth transition. So there's not enough colors between light orange and dark orange. So that's why you will see higher color bit depths in these situations. And it's all has to do with compression, and there are different types of compression. So first of all, it's lossy compression. It's irreversible, and it's mainly used to reduce the data size. Some examples like MP3, where you can remove, for example, the parts that your ear can't hear. So and the higher tones above 20 kilohertz or even above 16 kilohertz, for example, those are removed in MP3, and there are other things they do to reduce the data size, but it's irreversible. Another one is JPEG compression, and you can see the compression also here with the beer. So if you're not drunk, you will see a normal glass of beer. And compression is just like being drunk. You don't see it sharp any longer, and it's getting blurry. The image quality is heavily reduced in this right picture, but it can also be a less heavy compression, but still you lose information. On the other hand, we have lossless compression, and that's reversible, and that's a good thing. Otherwise, formats like zip or RAR won't be useful because you can't reverse it. Other formats are PNG for images, or FLAC for FLAC for audio, or Dolby True HD, for example, which you will find on a Blu-ray. Those are all forms of reversible compression. So you will lose some, or you compress something, but you can reverse it. And then one thing that Citrix invented is the term visually lossless, and it's irreversible, but the difference can't be seen by the human eye. So you do some compression, but you won't notice the difference. And one big item that's being used, a big thing that's being used in image compression, especially with moving images, is Chroma Sub-sampling. And it's used on platforms like YouTube, but also on Blu-rays, in games. And it reduces the amount of color information, but the picture clarity will be maintained. So our eyes are more sensitive to clarity or brightness than a small difference in color. And that's a good thing, because with Chroma Sub-sampling, we can even reduce the file size up to 50% by just dropping a heavy amount of color information. So how does this work? So with Chroma Sub-sampling, we will describe the color or the image with luma, the brightness, and the chroma, the color information. So the Y is the luma, and the U plus V, those are the color components. And with Chroma Sub-sampling 444, we will take the complete luma, the Y, and we will take the full color information. So you don't do any subsampling with 444. It's the original picture. The most common subsampling rate is 4:0, and it's in the right bottom. And you can still see we'll take the complete luma, so the brightness of the colors, but the color information is heavily reduced. So from these 8 pixels, or the block of 4, we will only take the left upper one. So the end picture looks differently than the original picture. But in if you have a 4K resolution, for example, with those many pixels, you won't notice a difference in moving images. But there's a downside. With still images, you will see the difference. So on the left side, we have 4:0 Chroma Sub-sampling, where you can see that the blue and red are starting to blur into each other, because we don't have that much color information any longer. So the pixels on the edge of the blue are merged with the red, so they are less clear. And on the right hand, you have 4:4 Chroma Sub-sampling, where you have the original compression, and it's really sharp. So if you use Chroma Sub-sampling together with text or still images, it's not that great for user experience. I can go on for, I think, at least half an hour about all these topics, but we don't have the time for that. Last year I wrote a comprehensive blog about it. So if you want to learn more about it, just go to my blog and pick a cup of coffee before you start, because it's tough to read, but it's very useful if you want to play around with encoders. All right, back to you, Patrick.
Yeah, but how does all the vendors have implemented the protocol compression? So if you look at Citrix Virtual Apps and Desktop, they have some different protocols. And the first one is thin wire. It's just basically JPEG compression, and will send JPEG over the wire. By default, the Citrix Virtual Apps and Desktop is configured with adaptive display, also known as actively changing regions. And this protocol will optimize the screen as best as possible. So for example, if you see the YouTube page, if you open the playlist, then you will see a moving video in the screen, and that will be sent with H.264, and all the still images part of the screen will be sent with JPEG, and the text is sent as clear text over the wire. So all Citrix decides which protocol is the best for which part of the screen. On the other hand, we have adaptive display called build to lossless, and what is new in 2003 version of Citrix Virtual Apps and Desktop is the enhanced build to lossless. Like Rodi mentioned before, if you do a lot of 2D CAD, then a YUV 420 is not good enough if you have a black background with the red lines. They will mix into each other and it will look like brown, and you don't see that very good. So you need YUV 444, but that's a lot of bandwidth. And sometimes if you don't have a GPU, a lot of CPU cycles. So Citrix and VAD invented the enhanced build to lossless. So when the screen is moving, it's sent with the YUV 420. And when the screen is still, then a JPEG is sent over the line to make those red lines in AutoCAD, for example, sharp. We also have the H.264 for the entire screen, which will compress the entire screen with the YUV 420. So this is the Blu-ray standard. And you can also configure this with the YUV 444. It's called the allow lossy compression. And then all the lines are sharp and you still have a full H.264 stream. You can also have the H.265. But then you need a GPU in your server, since this cannot be encoded on the CPU, and you need a decoder on your client to decode it, since it cannot be decoded on the CPU. They also have lossless compression, and then no data is compressed, and then you will fill all the bandwidth of the wire. If you look at VMware Blast or Horizon, the Blast protocol, they sort of doing the same, like they have a JPEG PNG compression. And if you have the Blast Extreme by default, it's H.264 with the YUV 420. So the entire screen is compressed. And it's also possible to configure it with the YUV 444 mode, and it's called high color accuracy, and that's the 2D CAD. Which is new from 7.10, it's the encoder switcher. And the difference between the actively changing region is that Horizon will switch the entire screen from JPEG to H.264, and it's not supported with NVENC. They also have H.265, and Horizon is also having H.265 with YUV 444, but we can't configure it in our test. If we look at Nutanix Xi Frame, they have fancy protocol names, like for the Google Chrome, they have the 061, and also an equivalent called HQ. It's the YUV 444, and those codecs are based on H.264. They have their own codec for Mozilla Firefox. If you look to WVD, they have their own protocol called Remote FX, and that's closed, so we don't know how exactly it works technically. And they're also able to do the H.264 in YUV 420 mode, like Citrix and Horizon, and also the YUV 444 mode. Okay, which visual clients did we test, and what was our lab setup? We tested some rich clients. It's a Windows 10 laptop. It's my Surface Laptop 3. We used a MacBook Pro and an Intel with Ubuntu Linux, and some thin clients like an iTool UD3 with the AMD Ryzen CPU, and computing workspace hub from Citrix, and a Raspberry Pi, and the Raspberry Pi 4. From the other hand, if you see the hardware from the server side, we have an HP Z4, and for the WVD environment, we have an V6 series VM, and you will see the difference between the GPU there. So for the 4 vendors, we configured, we tried to be the same as possible. So for Citrix and Horizon, we had the same image and just installed a different agent, both on vSphere. For Xi Frame, we have to switch on the same server to HAV, since they don't support vSphere. And for WVD, we have to spin up VM in Azure. Okay, the vendor native clients. All the vendor have native clients, and we created a screen capture of all those possible solutions. Like on the left-hand side, you will see the device with the OS, and on the right-hand side, you will see each vendor with their protocol settings. We will share this matrix after the session, but one thing is noticeable here, and that was surprising for us, is like Citrix is the only one not supporting the H.264 and YUV 444 modes on non-Windows devices. Like VMware is supporting that, like yes, And virtual desktops, Windows Virtual Desktop is also not supporting it, but the fallback behavior of Citrix is very annoying. Like they are now falling back to the thin wire, always lossless. Like if you configure this for your 2D CAD environment, then the fallback for if that 2D CAD user is Mac OS on the MacBook Pro, yeah, then the session will come unresponsive if he starts a YouTube movie or a lot of movement in the screen. Like the bandwidth is getting full, also with the CPU. Like the Windows Virtual Desktop has a fallback to remote effects, so the session will start working. So if you do 2D CAD in your Citrix environment and you have non-Windows devices like iJoule or Ubuntu Linux or MacBook, then it's better to use the build to lossless, enhanced build to lossless, which is new in the 2003 version. So yeah, you don't have that laggy user experience when not using a Windows native client over there. Oh yeah, one other thing is noticeable. We also try to test the Raspberry Pi 4 since that's a great client, but for some reason it keeps crashing. So we don't know why, and we raised a support case at Stratodesk. So if you look at the first movie, we did some Rex analytics over here. Okay, so on the left top, you will see the user experience. Oh. On a Surface Laptop 3, on the right top on my MacBook, on the left bottom on an iJoule with Citrix, and on the right bottom you'll see the user experience with Ubuntu Linux on an Intel NUX, both on Citrix. So we start the workload in Rex Analytics. It's a dead star. I'll just spin the load part. And you can watch the movie yourself on YouTube to see the actual frame rate. And there you see the difference in user experience. If you see at the left top, the dead star is spinning very smoothly on my Windows laptop. And if you see on the other devices, we will notice some frame drops over there, like it's now 8 frames per second. And there it's like 15 frames per second on my Ryzen.
Yeah, and you can also see the difference in CPU. So the Windows was like 6%, this was 40%. So that's a huge difference as well.
Exactly. Okay. What about the HTML5 clients? Like all the vendors are telling us like, okay, it works on any device because we're supporting HTML5. Okay, we for our test, we tested the Google Chrome and Mozilla Firefox. And yeah, there are tons of browsers, but we skipped the Safari, the Internet Explorer, the Legacy Edge, and Opera since yeah, they're legacy browsers.
Yeah,
And
the
if you
new
look
Edge,
into the
yeah, sorry, the new Edge can also be compared with Chrome because they both use the Chromium engine. So that's
exactly
the same browser. Yeah.
So the first thing in our journey to our HTML5 experience is the documentation of Frame. And they are telling us like, hey, if you're using Google Chrome, the decoding time per frame can drop to less than 2 milliseconds. So that's really fast. If you're using Firefox, then the decoding times per frame could be 5 to 10 milliseconds. Like, hey, there's some difference between Chrome and Firefox. If you're using Safari on a MacBook Air, it can be more than 10 milliseconds. Yeah, and if you look, if you're using still Internet Explorer 11 or Legacy Edge, it can also be up to 100 milliseconds. So don't use that for your HTML5 client user experience. So we concluded here and also in our test, like, okay, it runs in any browser, but the best user experience is with Chrome. And again, we make this matrix. We will share this afterward, and I will just share you what we've seen here. Like the first thing, what is noticeable is that Citrix is supporting all the codec types through HTML5. But hey, maybe that's also some kind of pitfall for them. Like we also have noticed that when you configure deactively changing region, it technically it works, but the frame rate and the mouse control is not acceptable in the HTML5 user session, and the same is for the build to lossless or the YUV 444 configuration. The other vendors block it. For example, if you're using VMware Horizon or Windows Virtual Desktop or Xi Frame, they just block the options for Firefox. On the other hand, we've noticed that when you're using an ARM-based device like the Workspace Hub or the Raspberry Pi 3, it's impossible to use HTML5 clients, since those ARM devices are too slow to support this. So again, we have two movies. I will just speed it up of time. Like the first one is the Chrome comparison. So we have all the vendors. Like in the left top, we have Citrix. On the right top, we have VMware Horizon. On the left bottom, we have Microsoft with WVD. And on the right bottom, we have Nutanix Frame over here. And all on Google Chrome on a Surface Laptop 3. And one thing is really noticeable here, if you see the frame rate on YouTube, is that Nutanix Xi Frame, which is originally a web-based vendor, they're the only vendor who's capable of doing a smooth frame rate when using the Dead Star in Chrome. I think Citrix is the second best, and Horizon and WVD, they're just very poor when using the HTML5 client in Chrome. And if we do the same for Firefox, so again, Windows 10 on the Surface Laptop 3, and on the left top you will see Citrix, and again Horizon on the right top, on the left bottom WVD, and on the right bottom you will see Frame. And I think you will see the same results as we've seen with Google Chrome, is that that Frame has the best frame rate over here. So yeah, test your device very carefully before using it with HTML5. Okay, just put it on pause. You can watch the movies after the session. So back to you, Rody.
Yeah, so the best or the common graphical settings that we would recommend with different workloads are, for example, for the office worker, which is a very general workload, using Office, using ERP software, using web apps, sometimes watching movies on YouTube or doing a video call. We would recommend to check the default graphic settings, because default graphic settings could change per release. So for Citrix, set it to HDX adaptive display. So it's a combination of JPEG, PNG, and H264, and also special text compression. And don't leave it to default, because currently this is default. But if Citrix for some reason changes this in the next release, you can have suddenly a quite different user experience. For the other vendors, you can leave it to default. With BLAS, you can set it to the switch encoder if you want, but that can't be used if you have a GPU in your system. And only adjust the frame rate or quality settings in specific scenarios. So if you have a high latency or low bandwidth, lower the image quality, or in the rest of the cases, just leave it on high quality, because your users would really like those high quality images. And those settings are compatible with the most known clients. So if we look at the difference between a thin wire encoder and a moving image encoder when using a moving image. So why do we need thin wire? Why do we need H264 with a moving image and not thin wire? So here the same scenario. On the left, we have H264. On the right, on the left, we have thin wire. On the right, the green one is H264 YOV420. And you can think about this moving image as a YouTube video. So you have a YouTube video running. With H264, we will get a smooth frame rate of 30 frames per second with a very low CPU usage. But on the left side, we will only see 7-8 frames per second with 40-50% of CPU usage, because thin wires just not made for moving images. So that's why for actively changed regions with Citrix or the switch encoder with Horizon is a very good solution for these types of things. Because the H.264, like I said before, isn't good for text. The compression and YUV 420, yeah, it's making the text blurry and hard to read. And you will get a headache at the end of the day if you have to read a few hundreds of pages of documentation or designs with these image qualities. With JPEG, PNG compression, it's much better, and it's preferable for those scenarios. That's why those switching encoders are the best solutions. On the other hand, with 3D workloads, you will have mainly moving images. So with Citrix, I would recommend to test with different settings, and it really depends on your situation what works best. But set the video codec for compression to the entire screen, the visual quality to build to lossless, which I would recommend. Otherwise, use the high quality. Use hardware encoding for video, set it to enabled. Allow visually lossless, set it also to enabled, and enable optimized for 3D workloads. If you combine the visually lossless with build to lossless, you will get YUV 444 build to lossless on Windows endpoints. On all the other endpoints, it will fall back to 420. And it really works well. So if you have sometimes documentation you need to read, then build to lossless is also a very good solution, because once the image is still, it will send a lossless image over the wire. So your text will be changing to a sharp image. For VMware Horizon, we would recommend to enable the H.264 encoder with BLAST. You could enable YUV 444, but yeah, for 3D workloads, it's not supported on every platform or runs well on every platform, and it doesn't fall back to 420 with Horizon. But just test with those settings. And for WVD, use H.264. There's a typo in it. It's H.264 and not H.2.264. But use it for with hardware encoding for the RDP protocol. But test your settings with a tool like RD Analyzer, so you can change your encoder and your quality settings. And remember that your client needs to support those remote encodecs, like having a H.265 decoding chip if you want to use it, if you want to lower the bandwidth. And it's also best to check if your endpoint has a H.264 decoding chip, because it will just run smoother.
Hey, with H.265, you can reduce the bandwidth to 40%, isn't it, right?
Yeah, that's right. But it can't run on a CPU decoding. So you really need an H.265 decoding chip, and not every device has it. But the most modern devices, thin clients, laptops, PCs do have it. So check before you try. So for 2D CAD workloads like AutoCAD, you want to adjust for still images and sharp lines. So you want to have YUV 444. So again, here set the video codec with Citrix for the entire screen. Quality build to lossless. If you don't work from home, you can set it to always lossless. But in a working from home scenario, you really need build to lossless. Otherwise, everybody needs at least 80 megabit of internet connection, and your ADC would need to have a 10 gigabit license if you have a few hundred people working on it. So really use build to lossless. Enable hardware encoding for sure. Allow visually lossless, set it to enabled, and optimize for 3D workloads. So you will have H.264 for the entire screen. And with Citrix, you will have YUV 444 built to lossless on Windows, just like the 3D workloads, and 420 on other platforms like macOS or Linux. For Horizon, there is no built to lossless, so you could set it to H264 high color accuracy, but with the working from home, yeah, you're in a twist there. So you need to use the standard YUV 420 with Horizon. Otherwise, your bandwidth usage is just crazy.
But one thing is also noticeable if when you're using YUV 444 and you don't have an GPU, or you're using an Intel Iris GPU, then you can't encode this on a hardware encoder. So you will have 4 times as high CPU load encoding the H.264 than using the YUV 420. So be careful with the YUV 444 if you can't encode it on a GPU.
Yeah. But with 2D CAD workloads, you would really need a GPU in your system or in your session as well. So use NVIDIA or AMD for that. WVD, you can prioritize H264, YUV 444 graphics mode. And the funny part is you can set it in a group policy to enable, but you need to check the event log or the event viewer if it's enabled. So you can't see it pretty quickly. But this will prioritize 444, and if your endpoint doesn't support it, it will fall back to 420. So there's a big difference also in terms of bandwidth, like I said, with always lossless versus built to lossless. So here we have on the left hand, we will have YUV 444 always lossless, and on the right hand, we will have YUV 444 built to lossless. And we're working from home here with a bit of a shitty connection, 4 megabit, but I think it's pretty common still in most countries. And normally, like I said, an always lossless is really great if you work in the office. But if you work from home in these COVID-19 times, you need a codec or an encoder that will drop the bandwidth usage. Because no, it's not the GoToWebinar why you will see a slideshow on the left hand. Because with always lossless, you need roughly around 80 megabit for a 30 frames per second image, and we only have 4, so we get 3-4 frames per second. But on the other hand, built to lossless is doing a really great job. And if you would pause the image in your session or the rotation in your session, it will quickly build up with a lossless image. But in the meantime, it will do a compression. So that's why you really do need to look at the built to lossless capability of Citrix. So Patrick, what did we learn during these tests?
We've learned a lot, and we will share all the videos in the next couple of months, so you can see it all yourself. But what we learned is try different clients per use case with your customer. And we mentioned it earlier in the session, there is a different user experience per operating system or even per device. Try different browsers on different devices, like a browser is also changing the user experience and also the underlying device. So try this if you heavily lean on HTML5 clients. For YUV 444 use cases, 2D CAD, for Citrix, use Windows client. When using the native clients, use Google Chrome. And if you're using Citrix and we still didn't adjust the typo, use enhanced built to lossless. Any browser is supported, but the best user experience is with Chrome. So if you're advising your customers to use the HTML5 browser, let them use Chrome. If you're using Linux-based thin clients like Igil or HP or Stratodesk, check the update cycles. Especially for GPU-based workloads, you need the most recent client. So you want to choose the thin client, which has the fastest update pace. So you're always using the latest and greatest. Client hardware is also important, for example, decoding for H.264, H.265. So before buying a lot of devices, check your hardware compatibilities and also check drivers. Like for especially with the Intel driver, we have seen a lot of green artifacts. So check those. Check that you use the right driver up front before rolling out all your thin clients. So again, to close the session, 3 key takeaways we gave you at the beginning of the session: get the basic knowledge of protocols to make the right decisions. That's what we try to do with all the magic stuff Rody was doing with the colors. Please keep in mind any place, anytime, but not any device. And again, test it in your environment with your bandwidth conditions and your applications. So for now, we will say thanks for joining our session. And hopefully we will see you next year at the EVC at the in-person event again. I like that more than the GoToWebinar part, but hopefully see you next year, guys.
Yeah, and we have one question for the audience. So we're starting to work on the 2021 edition because it's almost 2021. So please let us know what you want to have tested, or you have any ideas around our testings. Please share them with us so we can take that for the next one.